Well, this is exciting. It's completed. So GPT-5 disgraced itself with apparently buggy code, and now it's with its cousin OSS 20B to try and save the day. Let's run this. Oh wow, this is running. There we go. Okay. Well, it's done great. It has done great. Look at that. It's got the right answer, and it's also done it in crazy fast time. Let's have a look at the code. I can see that looks right. The subarray. It didn't mention that it's used Kadane's algorithm, but I can see that it has. There's only one loop, not multiple loops, and it wouldn't give the right answer if it had got it wrong. And so, despite it doesn't mention that it's re-implemented it. It just did it. There's no comments. It did it in perfect style. It continues to amaze. This is the result. This is the result from the small open source model. Here we go. Paste it in there. How amazing is that? It's just come in a hair under it's a bigger brother, which is perhaps just a coincidence. Who knows? But it's the number we're taking. That's the rule. I don't make up the rules. Well, I do make up the rules. But that's what we're going with. Congratulations. We've just got 2 more models to go. Okay, so next up is Grok 4, the mighty Grok 4. I've kicked it off. We'll let it run. Take one more moment to admire this nice user interface, which is all hooked up. As we look back at the code here, if I go back to this code just to show you, the thing that I didn't particularly cover last time is that you can see that the callbacks, when you call click for convert, it calls the port function as before, puts in the inputs of the model and the Python and takes the outputs. Then there's a Python run button. That's the new button. When you click that, it calls run Python, that function that runs and times the Python and puts the output in Python out. And when you click the run C++ or Rust, depending on what language is set to, it calls compile and run, that function that we wrote, and it puts the output there. So you see again that how cool and clear Gradio is just by setting listing the buttons and registering these events and tying them to callback functions, inputs and outputs. You can easily hook up a user interface to your model and to your backend callback function. All right, well, it's still running. I will see you in a minute when it completes. Okay, here is the Rust code generated by Grok 4. Taking a look at this. Okay, I can see that looks good. I'm not sure if, the right data types, I think. I think that looks good to me. And it looks like this is Kadane's algorithm, although it's not mentioning it. Exciting. Let's run the Rust. Let's see what happens. Here we go. Okay. And it's done it. It got the right answer. It got it in a very, very fast time. I'm not seeing, it's funny, it looks different. I don't know why it's faster. It does look like it's got a different implementation. I think that it's been quite clever with its sizes. For a moment, I thought it made a mistake, but I think it's been super smart with the way that it's done this. So maybe that is what's allowed it to get this number, but this is Grok 4's number. Let's put it with the others. Here we have our list. Down we go. And so Grok 4 is here. Is that the fastest so far? No, it's not. OSS 120 is still in the lead. It's the second fastest. One more to go. It's time for our prior victor for Gemini 2.5 Pro. Is it going to hold its first place or is it going to be dethroned by OSS 120? Okay, so we choose Gemini 2.5 Pro and we press the port to Rust button and we wait to see what happens. Very exciting. This then is the final battle for the ultimate victor, and we will let it do its thing, and I will see you in a second. Okay, we have code. We have code here. There's lots of stuff here, lots of comments like before. It mentions Kadane's algorithm, which is good to see. It's got stuff here. I hope that's not the same. I see stuff there that looks familiar from before. But let's now run this Rust and see. Drum roll, please. Drum roll. Here we go. Oh, yes, you see, I thought I saw that. formatting traits. So it's something wrong just with this print as before. How about that? How about that? And maybe it's something to do with the version of Rust that I'm running, which is the most recent version of Rust. I don't know what is causing this. I don't know enough about Rust. I'm a total rookie. I don't know enough about whether it's some way that I'm running it or implementing it or something. But we did tell it exactly the command we're using to run it. So it had that information. But shockingly, with a very similar error, we have just had our crown, our victor has been eliminated from the race. Gemini 2.5 Pro is out. Gemini 2.5 Pro is a fail, and that means that if we come back here, this is a fail, and shockingly, absolutely shockingly, or the one that did badly before, the open source model that was in last place apart from the fail, is now moved here to first place in our final tally. The first place, and this is shocking for so many reasons, but one of the ways it's shocking is it means that open source for the win, not open source running on my computer, admittedly open source running in the cloud because it's too big to run on my computer, but this open source model, OpenAI, GPT-OSS 120B is the victor, perhaps because of some technicality on now failed Gemini that comes in the failed list, comes down here. All of these failed. The only 3 that were successful was in first place, GPT-OSS 120B, in second place, Elon Musk's Grok 4, and in third place, another open source model, and this time running on my computer, GPT-OSS 20B, and everything else was failed. These are our 3 victors. Open source for the win. What a brilliant and shocking result. And there is one final point to make, which is how much faster was our native machine code compiled from Rust than the original Python. The original Python took 33.755 seconds. This was the faster code right here. That was the speed 0.000304. Let's find out how much faster it was. It was 111,000 times faster, more than 100,000 times faster on this hard problem. Wow. Wow. I hope your mind is officially blown. OpenAI GPT-OSS 120B, an open source model, took some perfectly respectable Python code, and by changing the algorithm, converting it to Rust that we then compiled to machine code and ran, we were able to achieve a more than 100,000 times speed up. That is a business outcome metric achieved. And with that concludes this section. I realized there was a lot of geeky stuff. We did a lot of things with C++ and Rust. I don't know whether it appealed to you or not, but hopefully, regardless, the outcome appealed to you. That is really cool, a really great result. And how fabulous that it was an open source model that won. This is very different from my result last year when I stuck with C++. And I got a 60,000 times performance improvement, and it was a Frontier, it was closed source that won. But this time it's open source for the win, perhaps because of a surprising disqualification. Nonetheless, we'll take it. Open source it is. All right, so now, the challenges for you. There are so many challenges that I want to go through about how you can take this project, take it in completely new directions, and do some really fun stuff with it. So first of all, recreating my results, trying it yourself, and add some different models. If you're using Llama, throw in whatever, try some coding models. I realize we use Grok 4. There's also a code version of that you could try to see if that gets the edge. There's so many different things that you could try to see what wins, and please share your results. I would love to see what kinds of results people get, so we find out who ends up being victorious. What is the final winner? And then importantly, so for anyone that's done my agentic course or that's done any exploration with agentic AI, this was very much a piecemeal, take a single file and convert it. Of course, this lends itself so well to an agentic solution where you have something that's able to iterate through all the files and port a full solution. So that would be sensational. So that would be a great challenge. You could start with just trying to read through a couple of files and then see how far you want to take it with multiple LLM calls. A very natural extension. And then the other thing to do, should you wish a bigger challenge, and others have done this, and you'll see this in the community contributions for many really cool solutions. One of them is to write a code tool that can automatically add docstring and comments. You can take that UI and then add them in and make it look really nice. Play with the Gradio UI, play with the callbacks. It should just be a quick callback, an LLM call. I think you'll be surprised how easy it is to build some of these things like docstring and comments, or convert to a different language. We've got here C++ and Rust. Put in something else. Let's see some Go. So that would be great. Writing unit tests. So put in code, get unit tests. Combine that with something agentic, and you can generate unit tests for your whole repo. And then if you want to take it a little bit further and do something more commercial and deeper, you could have a code generator that writes code that can trade on trading signals, buying and selling equities in a simulated environment. Again, it's a bit of a nod to something we build in my agentic course, but you could try that out yourself. And I put a little solution in the extras folder that you could look at, which generates code and tries to fine tune to get better and better at doing that. That's just a sort of extra thing to look at sometime. But yeah, you shouldn't do that yet. You should just write something that uses these API calls or Olama to write code that uses an API to find trading signals. So these are some interesting ideas, but also get creative. Think of a coding challenge you've got that you would like an LLM to help with and build that into here. And remember, the point of all of this is about coming up with a business metric, something you want to achieve, looking at the leaderboards to identify candidate models, and then seeing how they fare and how it actually accomplishes your business metric. So do remember, as you take on your challenge, follow the process, go through it, think about your evals, think about things in a disciplined way as a scientist, run your experiments, achieve great outcomes. I hope you get outcomes as sensational as our 100,000 speed up. And that brings us officially to the end of week 4. That is a wrap on week 4. You are now officially halfway on your journey to being proficient in LLM engineering. Congratulations. Now you're on the home stretch. You're in the second half. It's getting closer and closer to the end. But more importantly than all that, you're now heading into RAG week, the moment that so many, probably including you, have been waiting for. But already you can code with frontier models, and with Hugging Face transformers, you can choose the right model for your project based on metrics, leaderboards, and so on. And you can build solutions that generate code using frontier models and open source models, and you can be wowed by the results. Next time, you're going to be able to explain the ideas behind RAG. You're going to be able to walk through some high-level flows for adding expertise to your queries, and you'll be able to implement a toy version of RAG, a cheap and cheerful version. You'll do all of that on week 5, day 1, coming up tomorrow.